Good morning to everyone. My name is D. Karan Kumar Reddy, bearing roll number 244G1A0457. I am here to present my CAA2 assignment. My topic is using Verilog for shift register with parallel load and serial output. Introduction to shift registers. Shift registers are frequently logic device used to store and shift data. They can operate with serial or parallel data inputs and outputs. This representation focuses on designing a shift register with parallel load and serial output using Verilog. Types of shift registers. Common type include serial in, serial out, serial in, parallel out, and parallel in, serial out. The shift register discussed combines parallel load and serial output functionalities. Understanding their differences is key to selecting the right design for specific applications. Basic components of a shift register. Flip-flops are fundamental building blocks for shift register. Control signals like load, shift, and reset manage data flow. The clock signal synchronizes data transfer in the register. Verilog modeling basics. Verilog is a hardware description language used to model digital system. It allows for behavioral and structural descriptions of hardware components. Proper module definition and signal declaration are essential for effective modeling. Designing the shift register module. The module includes input for data, load control, clock, and reset. Outputs include the serial data output. Internal registers stores the data and manage shifting and loading operations. Port declaration in Verilog. Inputs typically include data in load, clock, and reset. The output is serial out, representing the serial data output. Internal wires or registers are declared for data handling. Behavioral description using always block. An always block sensitive to the positive edge of the clock handles data operations. When load is active, parallel data is loaded into the register. When shifting, data is shifted right and serial output is updated. Implementing parallel load. Parallel load occurs when the load signal is asynchronous. The data in bus is loaded directly into the register. The operation enables quick data updating without shifting. Implementing serial shift. When load is inactive, shifting occurs on each clock cycle. Data bits are shifted right within the register. The serial output provides the least significant bit after each shift. Complete Verilog code example. The code includes module definition, input or output declaration, and internal register. The always block manages load and shift operations based on control signals. Comments clarify each part of the implementation for better understanding. Simulation and testing. Test benches simulate different scenarios like loading data and shifting. Waveforms validate correct behavior of the shift register. Simulation helps identify and correct design issues before hardware implementation. Practical applications. Shift registers are used in data serialization, delay lines, and digital filtering. They are fundamental in communication interface like UART and SPI. Designing efficient shift register improves system performance and resource utilization. Advantages of using Verilog. Verilog allows precise hardware modeling and simulation. It simplifies the design process through the modular and behavioral descriptions. Reusable code facilities, rapid prototyping, and testing of digital circuits. Summary and key takeaways. The shift register with parallel load and serial output offers flexible data handling. Verilog provides an effective way to model and simulate this hardware. Proper understanding of control signals and data flow is essential for correct implementation. Best practices in Verilog coding. Use always at the rate block for sequential logic. Prior- Prioritize reset and load signals to avoid glitches. Test thorough roughly with compressive test benches before deployment. Serial output configuration. The serial output is typically connected to the least significant bit of the register. It provides a serial data stream for external modules. The serial output updates synchronously with the clock. Parallel load functionality. When the load signal is active, data is loaded directly into the register. This allows quick data updating without shifting. The load operation takes precedence over shifting in the logic. Declaring input and output in Verilog. Use an input keyword for signals like clock, reset, serial data, and load control. Declare output signals for serial output and parallel data outputs. Use appreciates width for parallel data such as n to 1 is to 0 for an n-bit register. Simulation waveforms. Waveform shows the register loading data in parallel mode. Shifting occurs when load is inactive, moving data serially. Reset clears the register, initializing it to 0. Complete Verilog code module declaration. The module includes input and output port declaration. Internal registers are used to store the shift register data. The code structure combines load, shift, and reset functionalities. Serial shift operation. When load is inactive, shift occurs on each clock cycle. Data is shifted by moving the bits towards the serial output. The serial input is shifted into the least significant bit LSB. Limitations and consideration. Timing constructed must be considering to ensure reliable operations. Larger shift registers may require optimization for speed and area. Proper reset and load control signals are essential for correct functionality. Conclusion and further reading. Understanding shift registers in Verilog is fundamental for digital design. Combining parallel load with serial output enhances flexibility in applications. For further details, consult Verilog HDL textbooks and FPGA vendor documentation. Thank you.